So in this video, we'll be learning about power series. The general format of power series looks like this. So it's going to be sigma of n is equal to 0 all the way to infinity. We have c of n multiplied by x to the power of n, where c here is the coefficient. So if we expand this, let's put n as 0. We're going to get c to the power of 0 multiplied by x to the power of 0, and x to the power of 0 is just 1, plus c to of 1 multiplied by x to the power of 1 plus c2 x2 plus c3 x3. So if you notice this is actually a polynomial, because you could have c0 as, let's say, -3, plus c1 could be 1 x1 plus c2 could be -99 x2, and so on, and this goes until infinity, right? Now another example of power series you might see is series of c to the power of n multiplied by x minus a to the power of n. So here your polynomial is actually getting shifted to the right or to the left. It depends on the value of a. So again, n is equal to 0 and all the way to infinity. Now if you expand this, put n as 0, it's going to be c0 plus c1 into x minus a to the power of 1 plus c2 x minus a to the power of 2, and so on until n is approaching infinity. Now what we call this a is actually the center. So here x is equal to a, and if we want to find the center over here, it's going to be center is x is equal to 0, since we don't have any number being minus or plus from x. Now let's say for x here in our first equation, let's substitute x as 10. So if we substitute as 10, it's going to be 10 to the power of 1, and then 10 to the power of 2, and then 10 to the power of 3, and so on, and they are going to be increasingly infinite, right? This means that it's going to be diverging. So the objective of power series is not to check if it's diverging or converging. It is to find an interval of x here in this equation which would cause this series to converge. So basically it's not a test. You're finding the values of x which would make this series converging. And the answer of x value could be not only one value, it could be more than one. So keep that in mind. So now let's start with a simple example. So question 1, we have a series of x to the power of n, and n here is equal to 0 all the way to infinity. And if we expand this, it's going to look like 1 plus x squared plus x cubed plus, and so on. And now we want to find the values of x here which would make this series converging. But before we do that, do you see any series which is similar to this? All we're doing here is we are multiplying by x each time, right? And that is geometric series. So our r ratio is equal to x. And if you remember, the rules of geometric series mentions if r, the absolute value of r, is less than 1, this means that the series is converging. And if it's more than 1 or equal to 1, it diverges, but we are not interested in that, so we can just leave that out. So here our r is x, so it's going to be absolute value of x is less than 1 for it to converge. Now how do we convert this absolute value into interval notation? So it is actually -1 less than x more than 1. So all I did here is expand the absolute value, and what we call this interval is called interval of conversion, and short form is just IC. So once again, let's start from the start. Let's start from the question again. We expanded the equation or the series, and we found out that each time we are just multiplying x from the last term. And this series is called geometric series, and our ratio is x. And from geometric series rules and for conversion, x or r ratio has to be less than 1 for the series to converge. Now our x is x, so less than 1 is equal to, we just expanded the absolute values, -1 less than x, more than 1, and this is our interval of conversion. Now another terminology that you need to know is called radius of conversion, and short form is ROC. And basically radius of conversion is half of the interval of conversion. And if you find the interval of conversion in units, it's gonna be 2, since if I draw the line here, -1, and we're not including -1 by the way, and 1 over here, and it's everything over here. So we're finding the distance, it has to be positive. It's a scalar value unit. So if we calculate this distance, it's going to be 2. Now 2 divided by 2, which is the half of 2, is just 1. So our ROC is 1. Now in some textbooks, the interval of conversion is also called disk of conversion. So what they are basically saying is you have to imagine this distance as the entire circle. Okay, let me draw it again. Okay, I'll draw it over here, and basically all of this distance is from -1 to 1, and we want to find the radius, which is from the center all the way to this line, which is going to be 0 to 1, which is 1. So let's do another example. Question 2. Sigma of n is equal to 1 of -12 to the power of n multiplied by x minus 2 to the power of n, and this goes to infinity. So let's put the initial few values to see the behavior of this series. So if we put n as 1, we are gonna get -12 multiplied by x minus 2 brackets plus 1 over 4 open brackets x minus 2 squared, and then minus 1 over 8 open brackets x minus 2 cube. So if you can see, each time we are multiplying it by -12 of x minus 2 brackets. And again, so this is our r, so let's take the absolute value. R is equal to this, less than 1. And now all we need to do is basic algebra to solve it and simplify it actually. So the first thing we can do is we can distribute the absolute value sign on both of the terms. So it's going to be absolute value of -12 multiplied by absolute value of x minus 2 is less than 1, and then let's bring this over there, so it's going to be half multiplied. Let's multiply both sides by 2. We are going to get cancel out this, and by the way, it was negative but positive because we have an absolute value, so here's going to be just 2. And now we need to open this absolute value bracket, absolute value. So we are gonna get either x minus 2 is less than 2, and then the other one is negative open brackets x minus 2 is less than 2. So this is how you open up the absolute value. And if this absolute value is not clear for you, let's take another example. Let's say the absolute value of x is less than 1. So what could the two possible intervals for x be here? It could be x is less than 1, or it could be that x here is more than -1, right? Because if you put anything more than negative 1 with absolute value is going to be more, it's going to be changing the sign, right? So the two values here that you can put in x to be 1 is negative 1 and 1. So that's the same case over here. All you have to remember is just bring the negative sign multiplied by the entire values, whatever is inside the absolute value, and less than 2. So that's there. So now let's just simplify it. It's going to be, let's bring the negative sign to the other side. It's going to be x minus 2 is more than negative 2. And here we're just going to bring the negative sign, negative 2, to the other side. It's going to be x is more than 0. And for the other one is x is less than 4. So our interval of conversion is 0 less than x is more than 0 and less than 4. So this is our IC. Now our radius is going to be the distance divided by 2. So this is 4 minus 0 divided by 2 is going to be 2. So our ROC is equal to 2. So now let's move on to our last question. It's a more complex question, so I need your full attention. Question 3, we have sigma of n is equal to 1, negative 1 to the power of n plus 1 multiplied by x to the power of n over n, and this is going to infinity. So let's expand. So let's put n as 1, we get x. Let's put n as 2, we will get negative x squared over 2, and the next term will be x to the power of 3 over 3 minus x to the power of 4 over 4, and so on. So one thing that we notice is we are multiplying by negative x over 2, and over here we are not multiplying by the same term, right? Because if we multiply by x, negative x over 2, you will get x to the power of 3 over 4, but here we have x to the power of 3 over 3. So geometric, this is not a geometric series. So what else can we use over here? What we could use here is ratio and root test. I'm gonna go with the ratio test since it's more easier here. So let me recall the rules. Let us recall the rules. It is limit of n is approaching infinity, and we take the absolute value of a of n plus 1 over a of n, basically the one term ahead over the last term, and we find the value. Let's name it L here, the absolute value of L. If it's less than 1, it is converging. If it is more than 1, it is diverging, and if it is equal to 1, it is inconsistent. So we don't care about these last two, we only care about what is the interval for converging here. So let's now start putting in the values. So it's going to be limit of n is approaching infinity of absolute value. Now one thing that we notice here is, as we recall, this could be a plus sign or negative sign, right? That's it. So all this part does is alternate the sign, but here we have absolute value. So even if it's negative, it's going to be turned into positive. So we can just completely ignore this part. Now the next part is x to the power of n plus 1. Remember that we are adding 1 to every n over n plus 1 multiplied by the reciprocal of a of n. So it is going to be n over x to the power of n absolute value. So here, what can we do with x to the power of n plus 1? We can rewrite this as x to the power of n multiplied by x to the power of 1, right? So here, we can cancel the x to the power of n with this part, and all we will be left with is x to the power of 1. So let's do that. And now, let's simplify this. So we are gonna get limit of n is approaching infinity of n over n plus 1 multiplied by the absolute value of x. And here let's use L'Hopital rule here. The highest power of the highest coefficient, or sorry, degree. So here is n to the power 1 and n to the power 1. So this part here is just going to be equal to 1 multiplied by x, the absolute value of x here. So let me rewrite that. So here the final answer would be just equal to, since this part is 1, all we left with here is just absolute value of x, which has to be less than 1 for the series to converge. And let's just rewrite this as the expanded version. So it's negative 1 less than x more than 1. Now this is a very important point. Whenever we are not using geometric series, we used ratio test over here or root test, we need to check both of the endpoints if they are included or not. So keep this in mind. Again, I'm repeating it. Whenever we are not using any test other than geometric series, we need to test out the endpoints. So let's do that to see if they are included in x, like less than or equal to, or they're just less than. So how do we do that? We go back to the original equation. So here we want to see what happens in the series if x is either equal to negative 1 or when it's equal to 1. So let's write it over here. X is equal to negative 1, and let's write the series again. So n is equal to 1 infinity, and we have negative 1 to the power of n plus 1 over x negative 1 to the power of n over n. And as we recall, our original equation was x to the power of n, and I just replaced x with negative 1. So now let's simplify this. So what here we can do is both of the bases are the same, right? So we can add the powers here. So let's rewrite it as negative 1 to the power of 2n plus 1 over n. Now I want you guys to notice something over here. We have n is equal to 1 all the way to infinity, and here we have 2n plus 1. So let's start by replacing with 1. We are going to get 2 plus 1, right, which is 3. And then when we put n as 2, we're going to get 4 plus 1, which is going to be 5. And this is like negative 1 to the power of 3, 5, 7, 9. So one thing that we notice here, we are never getting even numbers, meaning that this will always stay as a negative value. So here we can just neglect this part, since it doesn't really matter, right? It's just unnecessary stuff. And what does this series now look like? Let me write the series here. So n is 1, infinity, and we have negative 1 over n. Negative sign does not matter, you can take it outside. 1 over n is a harmonic series which is diverging. So we know that this negative 1, the value when x is negative 1, is diverging, so we don't need to include it. So it's going to stay the same. Now let's do it with 1. So let me just change this part and erase everything else. So here we have x to the power of n, so it's going to be 1 to the power of n, and we know that 1 to the power of anything is equal to 1, so we can just drop that n. And what do we notice over here? This is called an alternating harmonic series, right, which is converging. Since because of this alternating sign, our harmonic series, okay, my handwriting is not the best, or harmonic series diverges, or sorry, converges because of the alternating sign. So here the 1 is actually included. So the final answer of the interval of conversion is from negative 1 and x here, and then more than, or sorry, less than or equal to 1. This is our IC. So that's all for this video. I hope that you understood this topic. If you have any questions about any of the questions, feel free to ask in the comment section. I'll be more than happy to answer, and thanks for watching.